Hello, everyone, and welcome back to SNC1W. Just a reminder, my name is Jen, and I will be your guide and teacher as we navigate through Unit 2, shifting our focus to chemistry and the nature of matter. Within this unit, you will need to interpret, investigate, apply, analyze, and evaluate the following big ideas. Atoms are the building blocks of matter. There is a relationship between the atomic structure of elements, their properties, and the organization of the periodic table. Elements and compounds have specific physical and chemical properties which determine their uses, and the use of elements and compounds in consumer products and chemical technologies has both positive and negative impacts on society, the economy, and the environment as a whole. Without further ado, let's jump into the material. In this unit, you will explore the relevance of chemistry to your daily lives by investigating the use and safe disposal of various elements and compounds. Additionally, you will assess the impacts of chemical processes and technologies on society and the environment. You will also be investigating the nature of matter by studying properties of elements and compounds, the structure of atoms, and the relationship between the atomic structure of elements and the organization of the periodic table, and through hands-on investigation. Learning goals for this lesson include the following: explaining states of matter, explaining the classification of matter, and explaining properties of matter. You will know that you have successfully absorbed the information within this lesson when you can describe particle theory of matter, differentiate solid, liquid, and gas, differentiate pure substance and mixture, differentiate elements and compounds, classify different types of matter, identify the physical and chemical properties of the substance, and identify physical and chemical changes. The specific expectations targeted within this lesson include C2.5 and C2.6. On this slide, we will begin our discussion on matter. Matter is the physical substance that makes up everything around us. It is anything that has mass and takes up space. Mass is a measure of the quantity of matter in an object, and it can be measured in units such as grams, noted by a lowercase g, newtons, noted by an uppercase n, or kilograms, noted as a lowercase k and a lowercase g. Volume, on the other hand, is a measure of the amount of space that matter takes up, and it can be measured in units such as milliliters, which is noted by an lowercase m and an uppercase L, or liters, which is noted as an uppercase L. The states of matter, whether solid, liquid, or gas, can be explained by the behavior of particles. When particles are tightly packed and have a fixed shape, matter exists as a solid. When particles are loosely packed and can move around, matter exists as a liquid. And when particles have lots of space and are able to move freely, matter exists as a gas. Matter can also exist in a combination of these states, such as a solid-liquid mixture or a gas-liquid mixture. The particle theory of matter is a way of describing matter that asserts that all matter is composed of extremely tiny particles. Each pure substance has its own type of particles that differ from those of other pure substances. Furthermore, these particles are constantly in motion, with different types of motion depending on the state of matter. For example, particles in a solid may vibrate back and forth. Remember, these particles are tightly packed and thus have a fixed shape, while particles in gas move in all directions. In comparison, these particles have lots of space and are able to move freely. Lastly, particles in a liquid stay close together but can still slide past one another. The particle theory of matter also states that particles in a substance have varying degrees of attraction to each other. With this amount of attraction, being different for different kinds of particles, but all particles have space between them. As mentioned in the previous slide, matter exists in different states, and they can be solid, liquid, or gas. On this slide, I have summarized the previous points. Solids have a definitive shape and volume, and atoms are tightly packed together. Liquids have definite volume, but not definite shape, and atoms move around but stay fairly close together. Gases have no definite shape or volume, and the atoms move quickly and are far apart. So, as discussed, there are three main states of matter. These are solid, liquid, and gas. Each state is characterized by the arrangement of molecules or atoms and the amount of energy they possess. But did you know that many substances can change their physical states? To cause a change in state, you either need to add or remove energy in the form of heat. Adding heat energy to a substance can cause it to transition from a solid to a liquid, or from a liquid to a gas. This is because heat energy increases the speed and movement of the particles, allowing them to break free from their fixed positions and move around more freely. On the other hand, removing heat energy from a substance can cause it to transition from a gas to a liquid or a liquid to a solid. This is because cooling the substance decreases the speed and movement of the particles, causing them to come closer together and form stronger intermolecular bonds. Changing states refers to the process of matter transforming from one physical state to another. As we just discussed, these changes are caused by a change in temperature or pressure. One common example of a state changing is melting, where a solid turns into a liquid due to an increase in temperature. Think of the example of a solid candlestick melting when heat is added. Another change occurs due to evaporation, where a liquid turns into a gas due to an increase in temperature and or a decrease in pressure. This is part of the water cycle. Think of steam rising from a hot cup of coffee. This heat rising out of the cup helps the coffee to cool down. Condensation is the opposite of evaporation, where a gas turns into a liquid due to a decrease in temperature and or an increase in pressure. An example of this is when water droplets form on the outside of a cold glass on a warm day. When warm air makes contact with a cold surface, water vapor in the air condenses, forming droplets of water on the cooler surface. Freezing is the process where a liquid turns into a solid due to a decrease in temperature. An example of this is when water droplets from your roof freeze and turn into hanging icicles. An additional state change is sublimation, which occurs when a solid turns directly into a gas without going through the liquid phase. One common example of this is dry ice, or frozen solid carbon dioxide. When the dry ice is placed in contact with air, it gets converted into the gaseous carbon dioxide, which looks similar to fog. Deposition, on the other hand, is when a gas turns directly into a solid state on cooling, without going through the liquid phase. An example of this is the formation of frost or those frozen patterns of ice on your car windshield. In this example, frost is the deposition of water vapor. For example, humid air or air containing water vapor onto a solid surface. When a surface is at a temperature lower than the freezing point of water and the surrounding air is humid, solid frost forms. Matter can be classified based on its properties and composition. At its most basic level, all matter is made up of particles. These particles can be atoms, molecules, or ions. The types and combinations of these particles give every type of matter its unique set of properties. Properties can be physical, such as color, texture, or density, or chemical, such as reactivity or flammability. A substance can be described by its characteristic properties, which are specific to that substance. By understanding the characteristic properties of matter, scientists can classify and identify different substances. On this slide, you can see how one can classify matter. Here, the classification of matter can be determined through a flow chart, which includes multiple stages. The first stage asks whether the matter can be physically separated or not. If the answer is yes, then it is classified as a mixture. If the answer is no, then it is classified as a pure substance. Following the mixture route, the next stage asks whether the composition of the mixture is uniform or not. If it is uniform, then it is classified as a homogeneous mixture. If it is not uniform, then it is classified as a heterogeneous mixture. Now, if we jump back up to the pure substance route, our next question in regards to classification asks whether the pure substance can be chemically decomposed or not. If it can be decomposed, then it is classified as a compound. If it cannot, then it is classified as an element. A pure substance is a material that is made up of only one type of matter and has a distinct set of properties. These properties can include color, hardness, boiling point, or melting point. Pure substances can be classified into two main categories: elements and compounds. An element is a pure substance that cannot be broken down into simpler substances, such as gold. A compound, on the other hand, is a pure substance made up of two or more elements that are chemically bonded together, such as sugar. It is important to note that pure substances are further classified into either an element or a compound based on their composition and properties. As discussed, an element is a fundamental substance that cannot be broken down into any simpler substance through chemical reactions. The most important characteristic of an element is that it consists of only one kind of atom. This makes it the purest form of matter. Each element is represented by a unique symbol, which is typically a capital letter or a capital letter with lowercase letters. These symbols are used to represent elements in the periodic table, which is a tabular arrangement of all known elements based on their atomic structure and chemical properties. By understanding the properties of elements, scientists have been able to make great advancements in fields such as medicine, energy, and technology. In comparison, a compound is a type of substance that is formed when two or more different elements are chemically bonded together in a fixed proportion. A good example of a compound is water, which is made up of two hydrogen atoms and one oxygen atom, chemically fixed together to form the molecule H2O. On the other hand, a molecule is a group of two or more atoms held together by molecular bonds. The difference between a molecule and a compound is that a molecule can be made up of the same element, while a compound must be made of two or more different elements. Overall, both compounds and molecules are important in the study of chemistry, as they help us understand the properties and behaviors of various substances. A mechanical mixture, also known as a heterogeneous mixture, consists of different substances that are visible to the naked eye. The term hetero means different. One type of heterogeneous mixture is a suspension, which appears cloudy because tiny particles of one substance are held within another. However, these particles can be separated out when the mixture is poured through filter paper. Therefore, a suspension is also a type of mechanical mixture. Within a solution or homogeneous mixture, different substances that make it up are not individually visible. This means that one substance is dissolved in another, resulting in a uniform appearance through the mixture. The prefix homo means same, and all parts of a homogeneous mixture look the same. This type of mixture is often used in chemistry as it allows for precise control over the concentration of different substances. Homogeneous mixtures can be found in a variety of everyday products, such as sports drinks, household cleaners, and even medications. Overall, homogeneous mixtures are an important concept to understand in both science and everyday life. The properties of any substance can be divided into two distinct categories. You have your physical properties and your chemical properties. Physical properties are characteristics that can be observed or measured without changing the substance's identity. Examples of physical property include density, color, melting point, boiling point, and solubility. These properties can be used to describe and identify a substance. Chemical properties, on the other hand, describe how a substance interacts with other substances or undergoes chemical reactions. Examples of chemical properties include reactivity, flammability, and acidity. Chemical properties are often used to determine how a substance will behave in different chemical reactions. Understanding the physical and chemical properties of a substance is important in many fields, including chemistry, materials science, and engineering. By studying and manipulating these properties, scientists and engineers can develop new materials, new technologies, and improve existing products. Let's consider the following examples of chemical and physical properties. First up, we have oxidation. Oxidation is a chemical reaction in which there is a transfer of electrons between reactants. In simple terms, oxidation is the process of losing electrons. An example of oxidation is the rusting of iron. When iron is exposed to oxygen and water, it undergoes a chemical reaction in which it loses electrons and forms iron oxide, also known as rust. Melting point is a physical property that refers to the temperature at which a solid substance changes states from solid to liquid. Water, for example, has a melting point of 0 degrees Celsius or 32 degrees Fahrenheit. This means that at this temperature, ice, the solid form of water, will start to melt and turn into water, which is a liquid form. The melting point of a substance is dependent on factors such as atmospheric pressure, purity, and the presence of impurities. One way that I like to use as a way to remember how to distinguish between physical and chemical properties of matter is to remember that typically, when a substance undergoes a physical change, it can be usually reversible, as the identity of a substance does not change. Some examples of physical properties of matter are listed on this slide. These may include color, hardness, malleability, weight, electrical conductivity, solubility, and mass. Other examples include density, size, melting point, boiling point, length, and volume. The most important thing to remember is that a chemical reaction does not occur, meaning that the substance does not change. Additional examples will be given in the upcoming slides. As promised in the upcoming slides, we will delve into different physical properties and provide a brief explanation along with an example for each. Let's start with color and luster. Color is pretty self-explanatory. It is the portion of the visible spectrum of light that is reflected back from a surface. The amount of light that a surface reflects or absorbs determines its color. In simple terms, this refers to the hue or shade of an object. For example, gold is the color gold. On the other hand, luster pertains to the level of shininess or dullness of a surface. In our gold example, it would have a higher level of luster or shine versus substance like concrete, which is considered dull. Conductivity refers to the ability of a substance to conduct electricity or heat. A substance that conducts high levels of heat or electricity is called a conductor, with the opposite being an insulator. In our example, we learned that most metals are good conductors. Because copper is a very good conductor of electricity, it is often used to make electric wires. Next up, density and ductility. Density is the amount of mass in a given volume of a substance, calculated by dividing mass and volume. For instance, compare the density of pure water at 1 gram per milliliter to gold at 19 grams per milliliter. This shows that gold is denser than water. On the other hand, ductility refers to the stretchability of a solid, with ductile materials being able to be stretched into thin wires. Copper is a well-known example of a ductile material. Next up, we have hardness, which is classified as a substance's ability to resist deformation, indentation, or stretching. Mohs hardness scale from 1 to 10 is typically used to measure hardness. On this scale, the mineral talc is the softest substance at level 1, while diamonds are the hardest at level 10. Malleability is the ability of a material to be hammered, rolled, or pressed into various shapes without breaking or cracking. Examples of malleable substances include aluminum foil, gold, and tin. Lastly, viscosity is the resistance of a fluid to flow and is determined by its internal friction or the thickness of its consistency. When comparing honey to water, we would say that honey has a high viscosity in comparison to water. Water exhibits several unique physical properties. One such property is cohesion, which refers to water's ability to stick to itself. This characteristic is the reason why water forms beads on non-absorbent surfaces such as glass. Additionally, water also exhibits adhesion, which is the ability to stick to other substances. These properties are essential to life on Earth as they allow water to be transported through plants and to form surface tension, which enables certain organisms to walk on water. In summary, a physical property describes a characteristic of a substance that can be observed or measured without changing the composition of matter. In a physical change, the substance involved remains the same chemically. The substance may change form or state. However, all changes of state are physical changes. Consider the example of the boiling point. There will be a change of state from liquid to gas or water to steam, but no new substance is formed. Both are still water. The chemical identifier is still H2O for both. Same is true for solid ice melting into liquid water. Change of state has occurred, but both are still water. If you take the liquid water and freeze it, it will turn back into ice. Remember, most physical changes can be reversed. Chemical changes cannot. Chemical properties refer to the properties of matter that can be observed and measured only by performing a chemical change or chemical reaction. Chemical properties cannot be determined by touching or viewing a sample. The structure of the sample must be altered for the chemical properties to become apparent. These properties describe how the substance interacts with other substances and how it changes during a reaction. Some examples of chemical properties include the ability to absorb or give off heat, the ease of burning, the formation of gas during a reaction or when heated, the reaction with acids or bases, the reaction with water, and the change in color during a reaction. These properties can be used to identify a substance and to predict how it will react in certain situations. When observing changes in matter, we know a chemical change has occurred when two or more substances react and form one or more new substances. Remember, the key is that the new substances formed are completely different from the original reactants. Chemical changes occur when a substance transforms into a new substance with different properties. There are four actions that could potentially identify a chemical change. The first is change in color, which can often be seen when a substance undergoes a reaction. The second action is a change of odor, which can be a safety concern if the odor is harmful. The third action is a change of composition, which can be observed when a precipitate is formed or a gas is released. Finally, the release or absorption of energy in the form of heat or light is another indicator of a chemical change. Examples of chemical changes include the rusting of iron, the burning of wood, and the digestion of food in the body. On this slide, you can see some additional examples of chemical changes, including burning wood, as mentioned, rotting fruit when you bake a cake, using a battery, the souring of milk, exploding fireworks, cooking an egg, and photosynthesis. We will finish up with a summary and examples of physical changes versus chemical changes. As discussed, in a physical change, the matter changes its form, but not its chemical identity. For example, melting ice turns from frozen water to liquid water, but stays water. Chopped wood changes from a full log of wood to smaller pieces of wood, but again, still wood. Shredded paper changes from a full piece of paper to smaller pieces of paper scraps, but you guessed it, both are still paper. Can you use this reasoning for an example of mixing gray and green marbles? In comparison, during a chemical change, a chemical reaction occurs and a new product or products are formed. So, for example, when wood burns, it combines with oxygen and changes not only to ashes, but also to carbon dioxide and water vapor. The gases then float off into the air, leaving behind just the ashes. This is an exothermic reaction, meaning one that produces heat. The chemical change that occurs when a banana peel turns brown in the air is known as an oxidation reaction. In this process, oxygen from the open air reacts with a chemical that is in the peel of a banana called polyphenol oxidase. When vinegar and baking soda are mixed together, a chemical reaction also takes place. The baking soda, sodium bicarbonate, reacts with the vinegar, acetic acid, to produce carbon dioxide gas, sodium, and water. This reaction is known as an acid-base reaction or a neutralization reaction. Fireworks also involve a variety of chemical changes that produce colorful lights and loud sounds. Different chemicals are used to create different effects, but in general, fireworks involve an oxidation reduction reaction. This means that some chemicals lose electrons in oxidation, while others gain electrons in reduction, resulting in the release of energy in the form of light and heat. The colors produced by fireworks depend on the specific chemicals used. Before we say goodbye, I would like you to take some time to consider the following examples. Please classify each one as either a physical or chemical change. Please pause this slide until you have completed examples 1 to 7. Now let's review numbers 1 to 7. Tearing paper is considered a physical change. Burning paper, chemical change. Breaking wood is considered a physical change, while burning wood or having a campfire is a chemical change. Mixing Kool-Aid is a physical change, while cooking a cake is a chemical change. And lastly, heating water until it boils is a physical change. And with that, we find ourselves at the end of Unit 2, Lesson 1. Today we discussed all things matter, including the states of matter, the classification of matter, and the properties of matter. Next up, atomic molecules. That is all for today. Bye for now.